Hello there! Welcome to today's episode of Evolution 101. Like always, your hosts, Professor Zich,
Professor Murad,
will be taking you on the wondrous journey of natural selection. Today's program will focus on environmental pressures and the vulnerability it brings to the species living in that environment.
we will start off tonight's episode by giving you a little background information on natural selection and environmental factors which affect it.
The theory of how species have evolved has changed drastically over time. Aristotle believed that species were fixed and did not change. This is now seen as an archaic belief. During the mid-1800s, a scientist named Charles Darwin thought up a theory to explain the evolution of species and how it impacts those who thrive and those who do not survive.
His theory is called natural selection, and it is still strongly believed in and used throughout the science world today. His theory was comprised of four significant components. These components are
Variation. Organisms within populations exhibit individual variation in appearance and behavior. These variations may involve body size, hair color, facial markings, voice properties, or number of offspring. On the other hand, some traits show little to no variation among individuals. For example, number of eyes in vertebrae.
inheritance. Some traits are consistently passed on from parent to offspring. Such traits are heritable, whereas other traits are strongly influenced by environmental conditions and show weak heritability.
High rate of population growth. Most populations have more offspring each year than local resources can support, leading to a struggle for resources. Each generation experiences substantial mortality.
Differential survival and reproduction. Individuals possessing traits well suited for the struggle for local resources will contribute more offspring to the next
Natural
generation.
selection transpires through the interaction of the environment and the variability in a population.
Environmental change is a major contributor to natural selection. One slight change in the environment of a certain ecosystem can significantly alter the species living in said ecosystem. These species become very vulnerable as everything they are used to has now been stripped from them and replaced by a new and unknown environment. An ecosystem can be turned on its head as a species that once had dominant and superior traits become unable to sustain themselves under new environmental pressures.
Natural selection does not cause a new species to be produced, but rather allows a certain species to better adapt to its changed environment. This is done by the changing of the species' genetic makeup from one generation to the next. Now, this is not a process which occurs quickly, but over many thousands of years. If a species lacks a desirable trait which allows them to prosper under its new environment, it will die out and allow the species with the desirable trait to reproduce and thrive.
Today we will be focusing on the environmental effects on the peppered moth, insects, humans, and how it caused these species to become vulnerable.
So join us on this lovely night as we journey through the splendors of natural selection.
A classic textbook example of an environmental impact on a specific species is the peppered moth. The English peppered moth was typically an off-white color with black speckles that was distributed across its wings. In daylight, these moths would be well camouflaged while resting on speckled lichen which covered tree trunks. Some moths had a genetic mutation which caused them to be black. This posed as an obvious issue, as the black moth stood out while placed on top of white lichen. This caused them to be easy to see by their predators. Moths with a genetic mutation were not able to reproduce as they were taken down by predators. This meant that the moth without the genetic mutation possessed the desirable traits and were able to reproduce. During the 1800s, the Industrial Revolution struck England hard and in turn caused massive changes in its environment. Factories and homes in Britain started burning coal to power new machinery. Because coal is not burned cleanly, it created lots of black soot. The pollution from this soot caused the lichens which covered the trees to die, and soon this black soot settled on top of the trees. The once thriving white moths were now susceptible to predators. The black soot allowed for the black moths to be well camouflaged and the amount of time to reproduce. In cities, black moths were almost the only thing seen, but in the country, the white and lightly black speckled moths were still superior. This caused the evolution of these moths to be driven in different directions. City and country moths would become so genetically different that they would no longer be able to inbreed with one another, thus causing them to be two different species. The white moths were blindsided by the environmental changes that the Industrial Revolution brought upon them. This caused them to be vulnerable. Once the Industrial Revolution passed its peak, the lichens started to grow back on top of the trees, thus causing the black moths to be no longer desirable. The white speckled moths were superior yet again. This proves just how uncertain a species' future may be and represents the lack of security present within the animal kingdom.
So now we stepped inside the classroom to get a better understanding of how the Industrial Revolution affected lichen and the trees. So here we have a diagram of pre-Industrial Revolution. So this is what a typical tree trunk would look like in an English forest. And as you can see that there's lichen all over the tree, which gives the tree this sort of white color. And then we have the peppered moth, a normal peppered moth, which has lots of white. And you can see it's very difficult to determine where the lichen ends and the moth begins. And down here we have a peppered moth with the genetic mutation. And as you can see, it stands out extremely well, and I'm sure all predators would be able to see it. So all predators would be able to notice this, which means that all of the black moths would be eaten, while the normal peppered moths without the genetic mutation would survive. And if we walk over here, we see this is a diagram of a classic tree trunk in an English forest at the peak of the Industrial Revolution. And as we can see, that the black soot caused by pollution had caused all the lichen to die, and the soot settled on the tree. So now you see that the once thriving normal peppered moth stood out. So there's almost like switched roles. It's been turned up. The ecosystem's been turned on its head. So those who used to be susceptible to predators are now not. So you see the white lichen, the white spotted moth standing out, and the one with the mutation surviving.
As Professor Zitch had previously stated, the peppered moth is a prime example of a species becoming vulnerable to environmental pressures. But the moths are not only the ones to turn vulnerable. Insects are actually a great example of a species that have been affected by their environment. In this case, it is also due to artificial change. The use of pesticides to get rid of insects is widely used throughout the world. They are used to get rid of pests such as ants, spiders, or caterpillars. This was a very effective way until people started noticing that insects still lived after. It was discovered that continued use of the same type of pesticide to control insects' population can cause desirable changes in the gene pool for the pest, pesticide resistance. Pesticide resistance is very common and it can also happen after every generation. The reason that insects grow resistant is due to natural selection. When a pesticide is first used, a small proportion of the pest population may survive exposure to the material due to their distinct genetic makeup. So therefore, the ones that live and are immune to it will reproduce, while the insects that are not immune to it will not live and not reproduce. This will result in a new population that is made up of only the insects that are immune to a certain type of pesticide. Natural selection takes place. Right now, there are more than 500 species of insects, mites, and spiders which have some level of pesticide resistance. The two-spotted spider mite is a pest of most fruit crops and is most famous for rapid development of resistance to miticides and pesticides. The only difference with this environmental change is that it happens quickly as opposed to thousands of years. The insects are vulnerable because the ones with the undesirable trait die out right away. Also, these insects that are not immune to it could have had the desirable traits in this species, but because of the change, it will no longer be a use to them. What is even worse is that even though this certain type of insect is resistant to the pesticide, they're not safe. Humans have noticed this, and as a result, we keep making new pesticides to get rid of the pest for good. But these insects don't know if they will be immune and can control whether they are or not, so the only chance of survival they have if the desirable trait is needed. Again, Natural selection has different ways of taking form.
Both Professor Zich and Azar made very good points, but I will be talking about the natural selection and how hits close to home. Humans, even if we don't notice, go through natural selection and are affected greatly by our environment. We humans have many different skin colors. Some people are unsure to what the reason is, but it's just another example of natural selection. Skin pigment is controlled by the amount of something in our body called melanin. Melanin is a dark brown to black pigment that occurs in humans or animals' skin, hair, and irises. Dark and light people both have this pigment, but darker people will have more melanin in their body than somebody with lighter skin, and the same goes for dark and light eyes. Natural selection has chosen darker people to be in the more tropical areas that have hotter climates. The greater amount of melanin protects people from getting damages from the ultraviolet from the intense sun. This is because melanin acts almost as if it's a type of sunscreen. This high amount of melanin prevents an individual from sun damage or skin cancer. It is a fact that people with lighter pigments are 10 times more likely to get skin cancer than someone with darker skin. People in Europe are lighter and have less pigment also due to natural selection. Europeans have lighter skin because unlike the tropics, the sun is not as intense in Europe. Europe has cooler climates and the sun is not as intense. This causes them to have lighter skin because they don't need as much melanin. The lack of melanin is what gives people the pale look. This is also why they have light eyes. The problem with this is now we have more immigration and migration. We now have light-skinned people living in tropical climates and vice versa. This serves as a problem, especially in the tropical areas. Since they are not born there, they have not been part of the natural selection in this area. They have lighter skin, meaning they have less melanin, which results in their vulnerability. They will be exposed to the sun's harsh rays and not have enough melanin to protect them. They will not have desirable traits of dark skin and have an increased chance of skin cancer, meaning a potential risk of death. This is natural selection and showing those who are most adapted to their environment have a higher chance of surviving.
The peppered moth, insects, and humans are all three examples of natural selection occurring because of environmental pressures. Well, ladies and gentlemen, this brings us to the end of the show. Tune in next week when we journey to the Galapagos Island to find Darwin and find out a little bit more about natural selection. Good evening, and see you next week.
What is love? Baby, don't hurt me. Don't hurt me.